So good evening, everybody, and thank you very much for taking some time out this evening to hear a wee bit about the ocean and the fact that it's under pressure, but actually with immediate action, a difference can be made. I think that the first thing that is always of interest to folk is the fact that we have a single ocean, a unified body of water that's essential for life on Earth. And actually, it was the photograph called the Blue Marble from Apollo 17, which woke a lot of people up to realize that we have a massive ocean that is totally interconnected, that actually we are the blue planet. In terms of the volume of water that the ocean makes up, you can see the value there on the slide. It's 1.33 times 10 to the 21 litres. So that's an awful lot of water. But underneath that, I put how many Olympic swimming pools. So it's 520 billions swimming pools. But to put that into context, that's for every person on the planet. And there's over 8 billion of us. We could each have 65,000 Olympic swimming pools. So that gives you an idea of how much water is actually in our ocean. And as I say there, the ocean is essential for life on Earth. And I'm going to speak a wee bit more about that in a second, but I'd like to highlight a couple of things. First of all, you see where the Seabird Centre is there. I've marked that on the map, but I've marked two other aspects on this map. The first one is the Mariana Trench, and it's up sort of in the top right-hand corner of the picture. And why have I marked the Mariana Trench? Well, actually, it's the deepest place on the ocean at 10,984 meters. And the pressure down there in sort of that depth is 1,086 bar. Now, that's equivalent to having sort of 100 adult elephants sitting on your head. So that's a significant pressure. But the other thing is that actually it's very salty down there, more salty than, for example, the North Sea at 36 practical salinity units. But the other thing is that down in that depth, creatures exist. And two of them are the vampire shark and the zombie worm. So you get all sorts of things in there, the vampire shark and the zombie worm. Now, the zombie worm is a fascinating worm because actually what it does is it burrows into the bones of whales that have gone down into the depth. And then it secretes acid to dissolve the bone. And the fats that are within the bone are then absorbed by bacteria. And it's these bacteria that then feed the zombie worm. So we've got life down there. Now, the other place that I've identified is the Clarion-Clipperton fracture zone. And why have I identified that? Well, the Clarion-Clipperton fracture zone is an area that is full of what's known as polymetallic nodules. And these are nodules which contain magnesium, nickel, copper, and cobalt. And actually, are plans to consider mining that deep ocean, which is at about 4,000 to 6,000 meters. Now, about 2-3 weeks ago, a paper was published. And in that paper, it illustrated that actually there are about 5,000 recently discovered unknown species that have been found in exploration work in the Clarion-Clipperton fracture zone. They found something like 5,578 different species, of which only 436 were named. In other words, we don't know very much about it, but we're thinking about mining it to get these essential elements that are going to power our phones and power modern life. In other words, to help humans sort of live on Earth. But actually, what's the consequences of that for this particular area? Because one of the species, it wasn't only a new species he discovered, but it was a new order. And so what we're finding is that there's still masses that we don't know about this phenomenal part of planet Earth. And as I say, the part that is essential for life on Earth. But you don't actually have to go to the Pacific or go to the deep to see amazing colors, to see amazing biodiversity. All the pictures now before you are taken from round about Scotland. And we go from the plankton, Carenia mikimotoi, through the zooplankton, Calanus phamarchicus, which is an absolutely fundamental part of the ecosystem, to the very colorful Arctic anemia, the red fingers, and the daily anemone, the slugs, and indeed you see the Leucotiara octona, which to me, the inside of it looks a wee bit like the inside of the TARDIS. But one of the things that I've highlighted there in the top corner is the ocean quahog, Arctica islandica. Now, why have I highlighted that? Well, there's a good chance that when that little ocean quahog was actually born, Shakespeare was writing A Midsummer Night's Dream, because these particular animals will live or can live for more than 500 years. And again, this just gives you an idea of the diversity, the variety, the huge biodiversity that exists within Scotland's seas, let alone the ocean as a whole. And of course, this is a seabird centre event, and I couldn't put up something marine without having something about seabirds. And of course, here we've got the northern gannet, the black-legged kittiwake, and of course, the puffin. And I'm very fortunate because there are some puffins live about 25 miles down the coast from me. The black-legged kittiwakes in the pictures above, they actually only live about 1 kilometre where I am. And I go and visit them a lot. I think actually they get a bit fed up with me turning up every day with my camera and taking pictures of them. But what this hopefully illustrates is that Scotland's biodiverse environment is as rich as indeed the whole ocean. But it's not only the biodiversity that's important. I said that the ocean is essential for life on Earth. And indeed, one of the key things about the ocean is actually it produces 50% of the oxygen that we breathe. Because actually there's a lot of plants in the ocean producing oxygen. And in terms of our economy, it's worth about £4 billion gross value added to Scotland. That excludes the actual oil and gas industry, or 2.8% of the Scottish economy. So it's actually worth quite a lot. But the ocean gives us a huge amount, and the examples are in the wheel before you. There's the fact that in terms of provisioning, of course, we all recognize fish, shellfish as food, but it also gives us energy. It gives us seaweed. And of course, some people put seaweed in their gin, especially if it's Harris gin, to augment the flavors from that particular gin. But also in terms of provisioning, we get sand and gravel extraction, something not so much common around Scottish waters, but quite common around England. But interestingly enough also, there are chemicals, drugs, which we are finding in creatures from the ocean, which in examples there is Yondelis, and this is used to treat adults with advanced soft tissue sarcoma, which is about 1% of adult cancers. And it's actually found in an extract from a sea squirt. Now, it's not the sea squirt itself that makes it, it's the bacteria within the sea squirt. But it's one of many, many drugs that have been found that can be used to treat cancer, can be used to treat inflammation, or in the case of cone snail, a very strong analgesia can be obtained. But also, in terms of what we get from the ocean, there's the cultural aspect. I actually spent yesterday tea time, I went with my wife and we got fish and chips, and we went down to the local harbour and we sat there and ate our fish and chips. And it was fantastic. It was peaceful watching the waves. And Of course, more and more tourism recreation around our seas is increasingly important. And also it's recognized that people who live close to the sea actually live longer. So there's an advantage to living close to the sea. Wildlife watching is, of course, an increasing activity, but also in terms of spirituality and general health and well-being, we find that people enjoy being at the coast. But key other things and key other benefits from the ocean is in terms of storm protection, is in terms of carbon storage, is in terms of the fact that of the additional heat that has come about because of climate change, 93% of it has been stored by the ocean. The additional carbon dioxide that's been put into the atmosphere, about a quarter of that has been stored by the ocean. So the ocean is doing a massive amount for us, and we are gaining a huge amount in terms of not just the biodiversity, not just the food, not just the energy, and of course energy historically hydrocarbon, now renewable, but also in terms of the well-being, in terms of all the different things we get from the ocean. I would like to actually just, for a few seconds, jump into the atmosphere and speak a wee bit about the greenhouse gas effect. Now, we've all heard of greenhouse gases, and a greenhouse gas is basically a gas that absorbs and emits radiant energy within the thermal infrared range. And actually, the greenhouse gas effect is required for life on Earth as we know it. It's a perfectly natural process. And in fact, water vapor accounts for about 60 to 70% of the greenhouse gas effect. And it's what keeps the Earth's surface temperature at an average of about 15 degrees centigrade. However, one of the things that we are acutely aware of today is that there are other gases, carbon dioxide, methane, nitrous oxide, sulfur hexafluoride, which are also greenhouse gases. And what we're tending to do is put more and more and more of those into the atmosphere. And the consequence of that is we are increasing the thickness, if you like, of the blanket. And one of the things about the greenhouse gases is that if we give carbon dioxide a value of 1, then relative to that, water is only 0.2. But if you look at sulfur hexafluoride, it's actually 23,900 times more potent as a greenhouse gas than carbon dioxide. Methane about 25 times and nitrous oxide about 298 times. Of course, the concentrations in the atmosphere vary hugely, and the concentrations are above each of the chemicals there. And you see that carbon dioxide currently is around about 424.64 parts per million. Methane and nitrous oxide are in the parts per billion, and sulfur hexafluoride is in parts per trillion. So actually there's not very much sulfur hexafluoride around, but it's just as well when you see the power of it. But the net effect is that our actions, our emissions, are causing an unprecedented change in terms of the fact that we are increasing the concentration of these gases. And in fact, the changes that were occurring cannot be altered simply tomorrow. So let's look at this in just a wee bit more detail. And I'm going to focus in on carbon dioxide, because that's probably the one that most people are familiar with. And what you see here is a plot of the atmospheric concentration of carbon dioxide going back about 800,000 years. And what you see is the concentration of carbon dioxide has oscillated, and it's gone roughly between 180 and 280 parts per million dry air. So over the last 800,000 years, the concentration of carbon dioxide has varied. When it's been up about the 280, we've been in what's called an interglacial period, or a warm period. And when it's been down at about 180, we've been in a glacial period, so a cold period. And of course, ice has then extended much more over the Earth. So that's what's happened for the last 800,000 years. What's happening today? That is what is happening today. And in fact, not that long ago, just a couple of weeks ago or so, we crossed through 425 parts per million. Now, if you look at where we are today, and if you consider the fact that the difference between an interglacial period and a glacial period is 100 parts per million carbon dioxide, we have already put on another 100 parts per million since the start of the Industrial Revolution. But actually, a lot of that has happened in the last 60 or 70 years. So what you suddenly find is that we are pushing hard in terms of the concentration of carbon dioxide in the atmosphere. And we've gone to such a stage, 425.01 parts per million, that in fact, when the concentration of carbon dioxide was last at this value, and that's estimated to be about 3 million years ago, the temperature was about 2 to 3 degrees C higher than pre-industrial times, and the sea levels were 15 to 25 meters higher than they are today. So where we are now is in quite a precarious position in terms of impact. And there are consequences for the ocean. And indeed, Scotland undertook an assessment of the seas around Scotland. And the conclusion of that assessment was that the most critical factor affecting Scotland's marine environment is climate change. Because the impact of climate change has been to warm the Earth by about 1.2 degrees centigrade. But also I commented that the additional energy, 93% of it, have been absorbed by the ocean. So what we're actually seeing is we're seeing sea level rise. We're seeing sea level rise because of the thermal expansion of the water, but also because of the melting of the ice sheets. We're seeing sea temperature rise because of the absorption of the additional heat. We're seeing ocean acidification because as the carbon dioxide is absorbed by the water, what's happening is it's making the ocean more acid. And indeed, there's a monitoring site off Stonehaven, which is obviously just about 15 miles south of where I'm sitting at the moment in Aberdeen. And there, we think we're beginning to see the impact of ocean acidification on the shells of some of the creatures that are living about 3 nautical miles off the coast at Stonehaven. We're also seeing ocean deoxygenation. So actually, there are lots and lots of consequences of this increase in greenhouse gas concentration. And indeed, we are seeing the sea level rise, sea temperature rise, ocean deoxygenation, and ocean acidification. Now, if I can give you a wee bit of an example here, what this is the daily sea surface temperature. And although it's nominally of the world, it's from 60 degrees south to 60 degrees north. And this covers the period 1982 to 2011. And what I'm going to immediately direct you to is the black line at the top, the black wiggly line at the top, which ends in 2023. And what you see is the global ocean hit a new record temperature of 21.1 degrees C in early April 2023, 0.1 degrees C higher than the last record, which was in March 2016. Now, some of you have perhaps noticed that in the BBC that they're speaking about we're going into an El Nino period, having been in a La Nina period before. This is to do with ocean movement in the Pacific. And 2016 was a very high El Nino year. And in fact, that's contributed to 2016 being the warmest year on record. If you look now at 2023, we've already beaten that, and we're actually just going into the El Nino just now. So what you're seeing here is consequences. We are seeing also, if you look where 2022 was, it was greater than 2 standard deviations above the mean from 1982 to 2011. So significantly different to that time period. And if you also look where 2020 was, there's some sort of peaks there that are up at the high end. And, you know, if you were to think about being in slightly warmer water, it's going to have an impact on you if you're a fish or if you're shellfish or if you're a plant. And so we're seeing this temperature effect occurring, and in fact, on a global basis. If we also now, look, I mentioned sea level rise, and I mentioned the reasons why it's happening. It's happening because of thermal expansion of water, but also because of the melting of the ice sheets in Greenland and in Antarctica. And this is putting lots and lots of fresh water into the environment. But if you look at the global mean sea level, then what I've got there is I've got 3 values, one for 1993 to 2002, 2003 to 2012, and 2013 to 2022. What you see there is the mean across those decades was initially an increase of 2.1 millimeters per year, then 2003 to 2012 was 2.9 millimeters per year, but for 2013 to 2022, it's 4.5 millimeters per year. In other words, we're on an accelerating trajectory of global mean sea level rise. And indeed, the sea level around Scotland is going up about the 4 millimeters per year. And the consequence of this is flooding and coastal erosion. If I return now to sea temperature, what are the consequences of this? One of the big consequences of this is what's called trophic mismatch. Now, every animal needs something to eat. And so we have various trophic levels, starting off with the phytoplankton, then the zooplankton, and so on, up to the apex predators. But actually, unlike us, we take our tea, we put it on the dinner table and we eat it. In the marine environment, you have to go and find your prey. So the prey has to be there for the predator to eat it. But actually what we're finding is because of climate change, because of temperature changes, the prey may not be there for the predator to eat because they're no longer coming along at the same time. So what we find is that you may have mentioned Calanus marcicus, the copepod, isn't there for the sand eels. And what that means is that there's an effect on the kittiwakes that use the sand eels as one of their main food sources or energy sources. So we're seeing trophic mismatch. We're seeing increased respiration in some of the animals that are living in slightly warmer water. We're seeing species movement that's causing changes in biodiversity. But we're also seeing changes in currents. And if we're seeing changes in currents, then that can mean that for animals that rely on the currents for movement, they're now going to different places. But also, the ocean moves heat. The ocean is not static. The ocean moves heat around the globe. And if the currents are changing, then what you might find is that where that heat is going is not where it used to go. And actually, the United Kingdom is about 5 degrees C warmer than it should be for its latitude because of the North Atlantic current, which brings heat from the tropical areas to the United Kingdom. And if that slows up, or if that moves into a different form, then actually the consequences of this could mean a very different environment for us living here in the UK. And one of the other problems is there's a chance that we're going to move into what's called irreversible tipping points. This is points beyond which return is not very easy. But also what we find is that we've got the Arctic where we're seeing reduced sea ice cover. And that has 2 effects. One is the sea ice was actually reflecting back the sunlight. If the sea ice goes, then the sea can absorb that energy rather than it being reflected. So you've got a sort of a bit of a double whammy there coming in. but also in terms of the consequences of this. There are humanitarian consequences as well, because ultimately the changes in our weather patterns, the increased storminess and the increased severity of storms means that people are experiencing greater issues. The storms are coming through more quickly, they're more severe, and currently 3.3 to 3.6 billion people live in contexts highly vulnerable to the consequences of climate change. So big consequences. But the other thing I'd like to point out is that, I've been speaking a lot about averages. And one of the problems with averages is that it gives sort of a smoothed out representation, and there are regional differences. So for example, the Arctic, especially around Svalbard, is heating up many, many, many times quicker than the average for the globe as a whole. And actually what this means is that more than 1/5 of the world's population currently live in regions that have already exceeded the Paris Agreement's 1.5 degrees C of warming in at least one season. And one of the consequences also of this is that we see in the Sahel region of West Africa, temperatures are rising 1.5 times faster than the global average, diminishing water supplies, killing crops, and creating food insecurity. So we've got effects on land, we've got effects at sea, and we've got a situation where actually we're seeing environmental degradation. Now, it's not only climate change that's impacting on our ocean. One of the other issues is pollution, be it light, noise, nutrients, or chemicals that we're putting into the sea. We're also continuing to extract energy, food. I mentioned the nodules at the very start of my talk. Tourism puts pressure on coastal areas. But also as we move around, using the sea as a transport hub, we move species around and we can get invasive non-native species taking a hold. But also in our coastal areas, seagrass, mangroves, corals, they provide natural protection to the coast. And as these are lost, and indeed corals are really seriously at risk, then natural protection of our coast disappears. And the other thing that we're seeing is a loss of biodiversity. But human activities in all their forms, be it those that are producing pollution, those that are actually physically creating or moving things out of the sea, or energy or nodules, the tourism, are coming together with the impacts of climate change, the sea level rise, the change in the ocean currents, the ocean acidification, to really put our ocean under a lot of stress. To give you an example in terms of the contaminants, this is some data published in March this year, which illustrates a bit about beach litter. I mean, of course, I'd imagine some of you have been on beach litter cleans, but what I point you to is the map there. And on the map, what you'll see is a number of wet wipes found on beaches around about Scotland. And in the Firth of Forth, not too far, obviously, from the Seabird Centre, what you're finding is something in the region of 100 to 250 wet wipes per 100 meters of beach in the Forth. Now, of course, that is the highest areas, and in some areas we're not finding many at all. But, off Aberdeen, where I am, it's in the region of 6 to 10 wet wipes per 100 meters. But what this is illustrating is, again, humans are having an impact, in this case, littering our beach. Chemical contaminants continue to be a problem in the marine environment, and I'm just going to mention a wee bit about polychlorinated biphenyls. Now, these are human-made chemical compounds, and they've had many, many uses: coolants, lubricants, and transformers and capacitors, and they were also put into inks and adhesives and plasticizers. But actually, it was realized quite some time ago that these chemicals, because they tend to be in the environment for a long time, they're persistent, they also tend to bioaccumulate in the environment, they were banned 30 years ago. And the reason was because, as I say, they bioaccumulate, but also they tend to be toxic to not only marine creatures, but also to humans. They cause reproductive and development problems. They cause damage to the immune system and interference with hormones. They can also cause cancer. So they were banned in most forms over 30 years ago. This is some work actually from one of my PhD students, Alethea Majid, and what you see here is some data which we published just last year about concentrations in harbour seal and harbour porpoise. Now, these are top predators, so there has been a lot of bioaccumulation, biomagnification. But there we are seeing something in the region of 90,000 nanograms per gram lipid weight for PCBs in recent times in harbour seal, a bit less in harbour porpoise, but still big numbers. For chemicals that were banned 30 years ago, but they are still having an impact in 2023. And what this plot shows here is a wider area in terms of the concentrations of polychlorinated biphenyls. And what we see here is in the Irish and Scottish West Coast, we have fairly low concentration. Now, what the green dots mean is that the concentration is above background, but below what's called the environmental assessment criteria. And the environmental assessment criteria is a concentration above which you'd expect to see effects. Now, some of the PCBs are known as what's called dioxin-like, and they're more toxic. And CB118, which is the right-hand panel, is one of those. And what you see there is a number of red dots in, for example, the Norwegian Sea, the Northern North Sea, the Skagerrak and Kattegat, South North Sea, English Channel, and so on, Irish Sea, Iberian coast, which means that the concentration of that particular CB in fish and shellfish is above the environmental assessment criteria. In other words, this is a concentration at which we would expect to see some form of biological effect. And this work has actually just been published. So again, what we're seeing is that the chemical contaminants are there. And whether it's PCBs or polybrominated biphenyl ethers or other chemicals, chemicals are still having an effect. So a quick interim conclusion. Degradation of marine ecosystems, including through pollutants and contaminants, is accelerating, actually, due to unsustainable activities on land and in the ocean. But let us just take a deep breath. Let us just think about what we've heard. It's been pretty full on, and actually probably you're all feeling a bit sort of, oh dear me, this is not a good situation. Well, it's not a good situation, but all is not lost. And I say that because people have woken up to the fact that, first of all, the ocean is essential for life on Earth. We can no longer ignore the ocean. We can't use it as a dumping ground anymore. We can't just ignore it. We can't pretend that it's just there for us to make use of. We can't say that it's so big that we'll never impact on it. We are impacting on it, whether through climate change or whether through chemicals or whether through litter or whether through extraction. We are having an impact on it, but we are waking up to it. And I'd actually like to bring you right to the bottom of the slide, to the Montreal Protocol on substances that deplete the ozone layer. This was adopted in 1987. But interestingly enough, of course, it was adopted to ban the chemicals that were causing the hole in the ozone layer. But if you look what's happened, it's possibly postponed the occurrence of the first ice-free Arctic by as much as 15 years. And not only that, there was a report came out just a few weeks ago that says that because of the Montreal Protocol, we've avoided global warming by an estimated 0.5 degrees C. In other words, if it wasn't for the Montreal Protocol, we would be well through 1.5 already. So there was an unintended but very positive consequence from the Montreal Protocol, because not only has it happened to help the ozone layer, it's had a significant impact in slowing up the effects of climate change. Now, that's not to say that we're not going to have an ice-free Arctic too soon. At one point, people were saying 2050. Now we're saying sometimes in the 2030s is most likely. But actually, if it hadn't been for the Montreal Protocol, we might have been saying sometime during the 2020s. So action has been taken. And what you can see here is that action can have a significant impact. In this case, it might not be altogether what was intended, but it has had a significant impact. The other thing is that the United Nations has really got to grips with this, and it's set up what's called the UN Decade of Ocean Science for Sustainable Development. And I was involved in the formulation of this and trying to put some of this together. And what this is doing is saying, right, okay, the ocean is really important. And what we need to do is we need to generate the necessary knowledge to reverse the decline in the state of the ocean. We want to catalyze new opportunities for sustainable development of this massive marine ecosystem. So the United Nations are really pushing hard. Now, in the Northeast Atlantic, there's an organization called OSPAR, and it's what's called the Regional Sea Convention. And it reports every now and again, periodically, on the state of the ocean. And it's about to put out a new report, Quality Status Report 2023. And some of it's already online. You can go and see it. And this is going back to 15 governments and the European Commission and saying, this is the state of the environment. And this is what we're going to have to do to improve it. So there's direct engagement with governments to say, this is the evidence, this is what's telling us, this is what we need to be able to do. And of course, our own government here, the Scottish government, is designating by 2026, at least 10% of Scotland's seas as highly protected marine areas. Now, there's some controversy around this, but at the end of the day, the key message here is that action is being taken and information is being used, evidence is being gathered, technical measures are being put in place, government policies are being formed, and indeed action is having an impact. Now, the other thing, of course, we're moving towards is offshore wind and increasing the amount of offshore wind that is generated. And the green blocks on the map on the right, this is potential new sites. Now, we actually need to generate about 140 gigawatts of offshore wind by 2050. Currently, we're about 14. But what's important here is that we're not just simply going to put all this renewable structures into the sea. There's a big program called EcoWind. And the key thing here is we want to understand how interactions between species are affected by offshore wind and what this means for populations. Because we've come to realize that we can't just put stuff in the sea. And so we're investing £7.5 million in researching the impacts of putting renewable energy, which is absolutely essential. If we don't put renewable energy into the sea, then the sea will change. But what will happen if we do put all these structures into the sea? And key for this particular program, which is very different to other government-run programs, is that after year one, it's going to be feeding into government policy. It's going to be feeding in to the decision makers in terms of decisions around the placement of offshore wind. Now, also some other good news, if you like, is that one of the key things we all use is electricity. We all use it in our house. And yes, we should be looking extensively to reduce our consumption. That's something we can all be doing, switching off lights and switching things down and not using our tumble dryer at home and that sort of stuff. But things are happening, changes are occurring. And in 2022 was the first time wind generation, that's all wind generation, so onshore and offshore, provided over 20 gigawatts of electricity. And actually, the lowest carbon intensity month since records began was in February 2022. So what you can see is we are actually beginning to wean ourselves off the carbon dioxide producing energy generation. So again, changes are happening. And indeed, globally, there'll be an additional 440 gigawatts of renewable energy capacity. That includes solar and wind will be added in 2023. And there's actually solar power. The leaders at the moment are China. They're way ahead of anybody else in terms of the amount of energy. But the key thing here is that, yes, we want to reduce, but we're also beginning to transition away from the greenhouse gas generating sources. And that in itself will help. A key thing, of course, is us, people, you, me. And the Scottish Government did a survey in which they asked the Scottish residents what they thought about marine environment, what they thought about climate change. People clearly said, yes, we have an affinity with the sea. But actually, also, Scottish residents were concerned that not enough has been done to protect the environment. So actually, that's a good start. People are concerned that not enough's been done to protect the environment. But the worrying thing is that the majority of residents believe that it's government or business need to do more to protect the environment. But actually, it's everybody, it's all of us. And to that extent, what we all need to be doing is delivering clear and effective messages about what measures we can be taking to make a difference. Because be assured that just because you're only one person and you switch off a few lights, you think, well, that maybe won't make a difference. It will, because that would be multiplied many, 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 many times if we all do it. If we all use a little bit less power, if we all consume a little bit less, then actually, overall, that makes a huge, huge, huge difference. But actually, I've got a wee, what they call it, mnemonic, I think it is, to help you remember and to guide you as to what you should do. It's called the Scone Process. And this is what I think we all need to be doing. We need, first of all, to seek responses to ocean pressures. In other words, I've illustrated to you that wet wipes are a pressure on the ocean. So what's your response going to be to that particular ocean pressure? Is it going to be, well, I'm going to use less wet wipes, or I'm going to stop using wet wipes? Is it that you're going to be encouraging other people to use wet wipes less? So what is it that you're going to do? You've heard about the fact that, yes, the carbon dioxide that's produced from power generation is having an impact. So that's ultimately an ocean pressure. So what are you going to do about it? Well, are you going to, again, use a bit less power? Maybe not use your vehicle so much if it's one that generates CO2. But of course, electric vehicles as well, they're not without their problems in as much as they still produce particulate material of the tires, which has an impact on the ocean. A key thing also is we need to be challenging. We need to challenge constructively. We need to keep challenging, and we need to keep challenging with candor. And who is it we're challenging? Our local councillors, our MSPs, our MPs, and we need to keep challenging them, because ultimately it is the decision makers who will make the decisions that will change certain things. We want to be gathering in the information, taking it to them, speaking to them. And every time we go out and have a cup of coffee with someone, we should say, well, what about climate change? What about the impact on the ocean? What can we all be doing to help the ocean? We also want to observe the ocean. I mean, take time to go for a walk along an ocean path, go down to the beach, maybe go and do a wee bit of non-disturbing ocean animal watching, and absorb what you see. It is a phenomenal environment. But if you observe the ocean, if you understand the ocean, if you can bring other people to the ocean, encourage them to watch it, get them to understand the criticality of the ocean, then we'll get a change. But we must observe the clock. And what do I mean by that? We don't have a lot of time. The budget of carbon dioxide left that will prevent us from going through 1.5 is not very much. And we're perhaps going to use up that budget in the next 5 or 6 years. And they're actually predicting that sometime between 920 to 27, we will probably at some stage in one season, global average, go through 1.5. Now, we might not stay there, might fall back, but the clock is ticking. So we need to get people to the beach. We need to get people excited about the marine environment. We need to get people understanding the criticality of our single ocean, and that we do not have a planet B in terms of our ocean. So we really need to work with the one we've got. And this is also about networking. You know, as I say, whenever you're out with your friends or you're in the pub or you're out for a walk, hopefully a walk along the beach, speak to people about it, encourage people, because solutions are there. We simply have to think about using less. We simply have to think about changing our actions, being slightly less wasteful, making things last a bit longer, repairing things rather than discarding things. Because ultimately, this is about the impact of us, the impact of me, the impact of everybody on the ocean. And finally, we need to entertain. We need to tell the story that ultimately restores planet Earth. If we restore the ocean, we will go some way to restoring planet Earth. But as I illustrated earlier, there are effects on land as much as there are in the ocean. But if we can tell the story, if we can encourage people, then at the end of the day, if we are able to put in place significant adaptations, then change will happen. And indeed, all is not lost. So, in conclusion, the key messages I'd like you to go home with tonight are, first of all, the ocean is essential for life on Earth. We must act, whether it's reducing, reusing, recycling, responding. And we must do that now to reverse human impacts on the ocean. So actually, it's reduce, reuse, recycle, respond to reverse. Now, that doesn't mean to say we're going to go backwards ourselves, but actually we'll have a different experience. But that experience will mean the puffins and the seals and the guillemots and the crabs and the kittiwakes will be there. Our ocean will be there, because actually the ocean is what helps and facilitates life on Earth. Hopefully you're encouraged by the fact change is happening. The Montreal Protocol is an example of that. But through networking, through challenging our MPs, our MSPs, our councillors, our community councillors, we can challenge. And what we do need to do is we need to pick up the pace. Now, clearly, we don't just do this. We need to assess progress. And if it's not going fast enough, we need to increase it. And we may need to adapt our approach a bit, because not everybody will respond to the same sort of messaging. So how do we assess? How do we adapt? How do we approach? And finally, to not act is letting down ourselves, our families, and the planet. I have a grandson and I adore him. Now, in 2100, there's a chance my grandson will see that. What sort of planet is he going to see? What sort of environment is he going to experience at the later stages of his life? I hope that from what I've said tonight, from what you're seeing, that actually he will have a planet that is biodiverse, an ocean that is functioning, an ocean that's continuing to deliver, because we've taken action today. Thank you very much.
Thank you so much to Colin for that fantastic talk, some eye-opening facts and stories and research there, and some very thought-provoking comments and messages to take away for people as well. So thank you so much to Colin for that. So now everybody, we've got a chance now to ask Colin some questions. We've got time for Q&A now. We're going to use the chat as the way to ask those questions. So if you would like to ask Colin any question, feel free to type your question into the group chat, and I'll pick it up and I'll ask Colin the question. But if you do need to leave us, it's close to 8 o'clock. Thank you so much for joining us. We hope to see you at other events in the future as well. But I think I'll start off, Colin, with a question there. Great to hear you're passing on that enthusiasm for protection and conservation, trying to get people to act as well. You mentioned the fact that you want people to challenge, so you want people to go challenge MSPs, challenge councillors. How would you recommend people do that? How's the best way for people to challenge their local councillors and MSPs?
I think you should make an appointment and go to their surgeries, because I think actually face-to-face is really good. Before you go, get a few facts, write them down so that you're able to illustrate, especially if it's local. So, for example, just down the road from me is a colony of kittiwakes, and I go down there and I visit it. And if that starts to change a bit, then it's a bit of evidence to say, well, look, actually that's changing. So what can we do about it? So I think it is the case of getting a few facts. I always like the face-to-face because at the end of the day, it's a conversation. And it means that, you know, I tend to find emails or, you know, in these type of things, it can be a bit harsh. Whereas actually what we're trying to do is trying to get a message. We've got to sell the story. We've got a really good story to tell, a wonderful ocean that is under stress. But if we do X, Y, and Z, then actually we can make a difference. And of course, with the MSPs, they are the people who ultimately are responsible for our environment. They can take questions to the Environment Minister or whatever. They can help the Scottish Government make decisions around the regulation of activities in the sea.
Thank you. I have a question through from John. Thank you, John. He says, apart from China, is any country planning to control population?
Well, I don't know the answer to that, John. What I do know is that the population is continuing to increase. And of course, one of the key challenge we've got is the more people on the planet, the more resource that we're actually consuming. And just earlier this year, the human population passed through 8 billion. So there's a lot of us on the planet. And I think that's why we've really got to consider about this reduce and reuse and recycle and all the rest of it. And what's quite interesting, and obviously I didn't have time, I could have gone into it, the per capita use of energy. And some of actually the highest per capita energy use is in countries like Canada and Iceland, because as weather related and stuff like that. Other areas, it's much less. But the net effect is that there is a per capita use. So the more people that are on the planet, the more energy. But in terms of any action, I think that's beyond my beyond my remit there.
Thank you. I think let's have a look. Questions come through. Comments come through. So think about the highly protected marine areas has come through. So John Baxter's written that the fact we are now talking about HPMAs does mean that NPAs are not working. Would you agree with that comment?
I think there are challenges with marine protected areas. because when you think about, what is a marine protected area there? It's there to protect the particular priority marine feature that is in that area. And so what that means is that certain activities can still continue. And I think that the other thing is that in order to understand the impact of marine protected areas, what we have to do is sort of go out there and see what impact there has been. And I think that's quite a challenge to get them all surveyed and stuff like that. So I think that in terms of the effectiveness of marine protected areas, I think that we still have to do a lot of work to really understand how the ocean functions, and we still really have got bits of gaps in knowledge. So I think once we better establish that, we can then understand how we should better protect it.
Okay, thank you. Question from Barbara. She's asking, the removal of the 3-mile fishing limit years ago, which has gone on my screen, bear with. And now my mouse has disappeared, very unhelpfully. There we go. The removal of the 3-mile fishing limit years ago appears to have caused a significant depletion of marine species and destruction of the marine environment. Do you think it should be reinstated, and is there any move to reinstate it?
I think that with all these things, when we introduce change and we introduce effects, one of the hardest things actually in the marine system is to be able to concretely attach cause and effect, and to also be able to say that as a result of X, Y has happened. Now that's because of the massive natural variation that occurs in the marine environment. And so without looking at sort of the data in great detail, I wouldn't like to comment on the specifics, but what I would say is that it makes the gathering of information, the analysis of information, and the attempt to link cause and effect even more critical. And indeed, in Scotland's Marine Assessment 2020, a group of experts, 40 people, were got together in a room to try and look at this linking of cause and effect and what are the main pressures in the Scottish marine areas. And that proved hugely challenging to get the right information. And so I think that we really need to be gathering more information. And I know that sounds a wee bit of a cop-out, we need more information, but actually the natural fluctuation is so great, but also what we're seeing is, and it's a bit like it's a moving conveyor. Because of the rate of change due to the impacts of climate, we're actually seeing several effects. We're seeing a climate signal potentially, we're seeing a other human activity signal, and we're seeing natural variation. And actually trying to tease that out so that we are able to be able to say, right, okay, so this is what's caused that particular issue, remains a significant challenge.
Question from Martin. He asks, given the vast number of assessments already undertaken at many scales, why do you think politicians haven't got the message to do more yet?
I think that to be honest, there's a number of reasons here. The first one is that especially in recent times, there have been many things which have drawn the attention of politicians away from specifically environmental issues. The cost of living crisis clearly is a major impact on people. So I think it's partly that. It's partly also that in many cases, what we're doing, or the work we would be doing in the environment, won't see an immediate benefit today, but it will see a benefit in 5 years' time, 10 years' time, 20 years' time, and further down the line. And of course, from a political aspect, I often think that they like to see what they call quick wins, but you're not going to see quick wins in this situation. So it's a wee bit difficult to get that always to be top of the priority. And that's why I think we need to be going and knocking on their door and saying to them, look, this is the situation. This is what we think you need to do today, so that in 5 years' time, 10 years' time, and 20 years' time, we will see the changes. And I think that there is a change. I think the body of evidence continues to grow. And as that body of evidence grows, what we are seeing is it's a common body of evidence. There's, reports are not coming out saying, in one hand, it's terrible, on the other hand, it's fine. All the reports tend to be going in the same way. It's about loss of biodiversity, about increased temperatures, about reduction in pH and all that sort of stuff. So there's a common body of evidence, which hopefully now is at the stage of tipping the balance, but also it is about helping people to realize about the fact that the ocean is essential for life on Earth.
Absolutely, yes. And it's something we come across here. So a lot of my work at the Seabird Centre is I go out and I'll do events and I'll talk to people, and the word climate anxiety is around a lot at the moment, and that's people worrying about the impacts of that in their futures and feeling helpless almost to do anything about it. But as you said in your talk, Colin, it is that empowerment of the information people have, the ability to challenge people on it, and then that will push forward those changes in government as well. And I think certainly for my personally, it's been really nice to see all the climate marches and all the young people going out raising their voices about it, and they're making themselves harder to be ignored now. So I think certainly there is definitely hope for the future in that regard as well. Lovely. I think just double checking the chat, make sure I haven't missed anybody off. I don't think I have. I think that's all the questions. So I think that's all, Colin. Is there any last thoughts you want to share with people, last takeaway messages?
I think we just got to act now.
Lovely, brilliant, short, concise, to the point, wonderful. Well, thank you so much, Colin, and thank you to everybody for joining us. We're just sharing some links in the chat, so there'll be links to our future events that we've got coming up. So we do have more Meet the Scientist events coming up. We've actually got an in-person one here at the Seabird Centre in North Berwick. That's taking place on Tuesday, the 18th of July. That will be with the fantastic Jude Lane, who does fantastic research on the gannets on Bass Rock. So she'll be able to give us some insights into this year's season compared to last year's season with the impact of avian flu. So it'll be a really interesting one. So details about that will be available shortly on our events page on our website. And our next online Meet the Scientist event will be in October, date to be confirmed, but that will be with student Isabel Key about her fantastic research on seagrass as well. So loads of amazing people out there finding more information. As you said, Colin, those necessary data we need to find out more to help protect the environment and things that you can tune into as well. But in the meantime, if you guys have a spare moment and give me some feedback about tonight's event, would be really appreciated. We really want to keep running these events, so knowing what events and topics you want us to do more in the future, how we can improve it would be really great. So there's a link to the chat in there as well. That's everything, everyone. Thank you again for joining us. I hope you enjoy the week. Bye.